Hey, hello, good morning, dear Swift learners. How are you all? I hope that you all are safe and sound at your homes. And here I am back with another new session for you all. So, today we are going to do another session of light, and before that, we will be having a quick tour on Swiflearn to see what is Swiflearn all about. Swiflearn. It's India's most sincere learning destination wherein we provide the classes for grade 1 to grade 10. You will be experiencing live and interactive classes here with batches of maximum 6 students. Apart from teachers, we also have academic mentor team to track your progress and to guide you throughout your sessions. Plus, we also cover the syllabus as per your school exam schedule so that you can perform amazingly well there also. Then, some of the key features of Swiflearn includes detailed progress reports. So, by the end of every 2.5 months, you will be getting a detailed progress report, which will be a kind of analysis of what you have been doing in your classwork, homework, practice test, etc. Then we have Swiflearn academic test series in which you can compete with the students of your grade and you can see where do you stand and what are the things that you need to improve. You can also take unlimited practice test, which includes 2 categories of subjective and objective. So subjective test, it will further help you to score in your school exams. So just book your free trial class and experience all these amazing things by yourself. And also please subscribe to the channel of Swiflearn, press the bell icon and click on thumbs up if you like the video. Alright, so today we're going to move into another session of light energy in which we are going to study about speed of light, constituents color of white light, subtraction of colors and colors of an opaque object. So let us quickly get started, but let's recall first. Talking about reflection of light. What is reflection? So reflection happens when any ray of light, it strikes or it approaches any smooth surface and that light ray bounces back. So that phenomena, it is known as reflection of light. So let's see if this is incident ray which is coming from any source. It is striking a mirror which is highly polished surface. It is bouncing back, okay, making the same angle. So that phenomena is known as reflection. Now, we also studied about images, real and virtual. So let's see the properties and features of real and virtual image. So real image, it can be seen on screen and it is always inverted, upside down. Then it is formed when rays of light after reflection or refraction, they actually meet at some point. And it is formed due to actual meeting or intersection of light rays. And virtual image on the other hand, they cannot be formed on the screen and they are always erect. And here the light rays do not actually meet, but they appear to meet at single point. And it is again formed due to imaginary intersection of light ray, which is not real. Now let's do an activity to see if light travels in a straight line or not. Ignite a candle. We will be just igniting a candle and taking a rubber pipe which is hollow from inside. Okay, we will be holding this rubber pipe in a straight way and then we will be trying to observe the candle flame. And second way, what are we going to do? We are going to bend the rubber pipe a little and then we are going to observe the flame of candle. Okay, so first situation, we will be observing it through straight rubber pipe, and in second thing, we are going to bend it a bit. Okay, and then we will be trying to look through pipe. So what are our observations? So when rubber pipe, it is straight, it's very easy to observe this flame. But once we tilt the rubber pipe, we are not able to see the candle flame. Now, why does this happen and what does it prove? It happens because we cannot see light from bent rubber tube, which proves actually that light only travels in a straight line. It cannot move through the bends. So that the conclusion becomes light travels in a complete straight line. Now here light, it is made up of small packets of energy which are known as photons. And these photons, they travel in a straight line and the speed is very high. So light can move through small apertures and holes also, and it can change direction, but it will be very distinct. Okay, they will always travel in straight line. So if we make a hole also, we are able to see the light in a very straight line, right? So that proves that light always travels in a straight line. Now, from the previous experiment we saw that light travels in a straight line, but what is the speed of light? So if I talk about speed of light, it's very high. It is 2,99,792 kilometers per second, which is approximated to 3 into 10 raised to power 8 meter per second. So the speed of light is very high. It is 3 into 10 raised to power 8 meter per second. And the distance which is traveled by light in 1 year, it is known as 1 light year. Distance which is traveled by light in 1 year, it's known as 1 light year. Now, during Diwali time or during whenever we are burning the crackers, okay, what do we observe? Do we hear sound first or we see the light first? So we see the light first and then the pop sound occurs. That means the light has greater speed than that of sound. And we just now saw what is the speed of light. It is 3 into 10 raised to power 8 meter per second. Okay, so now there is a very interesting activity. We are using scale for drawing lines and for various purposes, right? But have you ever tried to hold the scale in front of your eyes and seen the tube light? I'm sure many of you have done it, right? When we are young, we just have this habit of playing around with objects. So when we see this scale or when we see the light through the scale, what do we observe? We observe various colors. Okay, but since on outside there is just white light, where are we observing these various colors from? So these colors, it is white light, it is consisting of these 7 colors which we are able to see through the scale. And these 7 colors are also present in the rainbow, and we all know the name is Vibgyor, right? So the colors, the sunlight, the white light, it splits into 7 colors which are violet, indigo, blue, green, orange, red. So we have blue, green, yellow, orange, red. So these 7 colors band actually is known as Vibgyor, and that is what white light is composed of. So when we are mixing all these colors in equal proportions, we get one single light, and that is the white light. Now let's carry a small activity to see that sunlight has different color. So what do we need? We need a glass prism, a white wall, okay, and a white wall is needed because the band of 7 colors, it will be produced there. Okay, so the prism, what it will do whenever we produce or whenever we give a light to the prism, it will split that white light into 7 colors and we will be able to see it on the screen. Now what is this phenomena of splitting the light into colors, into constituent colors known as? It is known as डिस्पर्जन. तो डिस्पर्जन क्या होता है? जब वाइट लाइट को हम प्रिज्म से पास करते हैं तो आफ्टर गेटिंग आउट फ्रॉम द प्रिज्म वो अपने 7 कलर्स में डिस्ट्रीब्यूट हो जाती है, ओके, स्प्लिट हो जाती है, एंड दैट स्प्लिटिंग ऑफ वाइट लाइट इनटू 7 कलर्स, इट इज़ नोन एज डिस्पर्जन ऑफ लाइट. So this is how dispersion occurs. We are having a light source, it may be sunlight, torch, anything, okay, and when this white light passes through prism, it is dispersed or it is scattered into its component colors, and this phenomena, it is known as dispersion of light. So it actually proves that sunlight, it consists of several colors, and 7 colors are there, right? And sometimes what happens after rain, when we see rainbow, it's possible that at times we are not able to see all the 7 colors. And why does this happen? Because the colors, they actually overlap each other. एक के ऊपर एक आ जाते हैं, so they kind of mix, and that is why we are not able to see all these 7 colors distinctly. Okay, now the degree of bending of light's path depends on the angle that the incident beam of light makes with the surface and on the ratio between refractive indices of the two media. That process is known as Snell's law, and it results in splitting all 7 colors present in white light. So what is happening कि कोई भी light कितना bend हो रही है वो किस पर डिपेंड करता है? फर्स्ट ऑफ ऑल इट डिपेंड्स ऑन द एंगल which the incident beam is making with the surface, and secondly it depends on the ratio between the refractive index. Okay, so we are having two surface जिससे light आ रही है और जिस पे light fall हो रही है, so it depends on their ratio also, and this particular thing, it results in splitting the 7 colors which are there in a white light. If I talk about dispersion examples in our daily life, the most common example is the rainbow in sky, which is visible after rainfall. Also during rainy days, what happens when roads are wet, okay, and if by chance the petrol falls on the road and it mixes with the water, then also we are able to see this kind of color, okay. So this is also again scattering phenomena. Then soap or the bubbles, the blowing bubbles that we have here, also we can see the dispersion of colors. CD, the most common example, we are seeing the various colors with cure. Now talking about primary colors, so red, blue and yellow, these are primary colors. All the colors, they are made by mixing them, okay. So if we mix red yellow, we get orange. If we mix blue yellow, we get green. If we mix red blue, we get purple. So from these combination of primary colors, we are getting secondary colors. Now what is meant by a color subtraction? Let us see. Now if I talk about white light, it consists of three primary colors, right? Red, green and blue, okay. If I talk about a white shirt, okay, if white light is shining on a shirt, then red, green and blue, these three colors are shining. But if the color is if the shirt is absorbing blue light, okay, only red and green light will be reflected from the shirt. So whichever color it is absorbed by any object, the other colors get reflected. So what is happening? Red, green and blue light, they shine upon shirt, and only red and green light will be reflecting from that particular shirt or from that particular object, okay. And this red and green light which is reflected, it is striking our eyes, okay, and they will be giving us the appearance of yellow. So shirt का जो color है, that color of the shirt, it will be appearing yellow. Why? Because this red and green light it will be striking our eyes, and that gives the appearance of yellow color. Now let us see the process of color subtraction. So in this process, the ultimate color appearance of an object, it is determined by beginning with a single color or mixture of colors and identifying which colors of light are subtracted from original set. Now if I talk about white, okay, so here white minus blue, okay. So white is a combination of red plus green plus blue, right? And if we subtract blue from it, what we will get? BB gets cancelled and red plus green, and red plus green, it gives us the look of yellow. Next, if I talk about only blue and green primary colors of light, okay, if I talk about these, so what are we doing? We are subtracting blue light, okay. So C minus B, so cyan is green plus blue, so green, if we mix with blue color, we get a cyan color, right? And if we subtract blue from it, then we will be seeing it in green color. So the shirt, it will appear green in green color in the presence of cyan light. So from these examples, we can see that the shirt, it looks yellow when white light is shining upon it, and it will look green when cyan light is shining upon it. So it depends on which light it is shining and which colors it is reflecting. Now test your understanding of these principles of color subtraction by determining the color appearance of the same shirt if illuminated with other colors. So we are going to take other color examples, okay, and then we are going to see what color will be reflected by the shirt and what color will be visible. So let's start with the A. So if magenta color, okay, magenta, it is actually mixture of red and blue color, okay. So it appears a kind of purple red, so it's mixture of red and blue. What is happening? Blue light, it must be subtracted since it is absorbed. So while subtracting the blue light from red and blue, what do we get? Only red, so the shirt will be appearing red. Next, red, again it is a primary color, so blue light would have to be subtracted if present. Now here no color is present, no other light is present, okay, so we do not need to worry about it. And red light is reflected and shirt will be appearing red only because the red color is primary and we do not need to subtract anything from it. Now talking about blue, so blue is also the primary color, Now we are subtracting blue color, okay, and here no color it is left to reach our eyes. Now this is very important. If blue color it is coming on any shirt or any object, now we are again subtracting blue, so blue minus blue it will be 0, so no color it is left to reflect to our eyes, and since no color is left, it will be appearing as black color. Okay, so the shirt appears black since black shows the absence of any reflected light. Now, have you ever wondered why you see through glass but not through walls or books? Transparent objects and opaque objects. So the objects which allow us or allow the light to pass through any object, they are known as transparent object, and we are able to see very clearly through these objects. On the contrary, if I talk about opaque objects, so these objects, they do not allow light to pass through them. They block the way of light, and hence we are not able to see through them. Now, the color of any transparent object, it is determined by wavelength of the light which is transmitted by it. An opaque object, what does it do? It reflects all the wavelengths which appear white. Okay, and that is why we are not able to see through the objects. Now, talking about what determines the color of an opaque object. So the color of an opaque object, it depends on the wavelength of the light that it reflects. Now if I talk about red object which is observed and which appears red, it is because it reflects only the waves which produce red light. If I talk about apple, see, we are seeing it in red color. Why? Because it is producing or it is reflecting the waves which produce red light, and that red light, that wavelength reaches our eyes, and that is why we are able to see it in red color. Okay, now questions time. What happens when light strikes an object? So whenever light strikes an object, it bounces back, and that phenomena, it is known as reflection of light. It also can happen, the light can also disperse, or light can also be refracted. So three phenomena happen: reflection, refraction, or diffraction or scattering of light. White light, it is made up of all the primary colors. And how does the color of transparent material determine? So color of the transparent material, it is determined through the wavelength. Okay, so we are having here answers. Okay, so white light, again it is made up of these sunlight colors which is Vibgyor, and the color of transparent object, it is determined by the wavelength of the light which is transmitted by it. Fun facts say that sunlight, it can reach a depth of around 80 meters, which is 262 feet in the ocean. A red ladybird, again, why do we see red ladybird as red? Because its body is reflecting the red light which is reaching our eyes. Challenge of the day asked that Rajesh, for observing dispersion of light, used a light from laser torch to fall on a prism. Will he be able to observe band of 7 colors? Now, if this is a prism and light is passing through it, it is splitting into 7 colors, and that is how we are able to see the band. Okay, so here we need a light source. But if I talk about laser torch, okay, laser torch, it is monochromatic source of light. Okay, so it will just give one color, and we will not be able to see the band of 7 colors. So we do not need a laser torch here. We need a simple torch would work. Alright, the mixture of red and green, it gives yellow light. The distance traveled by light in 1 year, it is known as light year. And dash, green, blue and yellow are termed as primary colors. So red, blue and yellow are primary colors. Alright, so what are the things that we have learned today? We learned about speed of light, the constituent of white light, and how to subtract the colors. What are the colors of an opaque object? I hope that you might have understood every single thing that we covered in this chapter today. We will be meeting in next class, in which we will be learning about more things. And also, please book your free trial class on Swiflearn and have this amazing experience. And if you have missed out on any video from this particular series, just go to Swiflearn channel. The videos are listed there. So let's meet in the next class. Thank you everyone.